Hello everyone, welcome to our channel. Let's learn together. In this video, we'll continue with the standard forms of Laplace transforms. Please do check the previous videos also where you'll find the other standard forms of Laplace transforms. So let's start with this Laplace standard form of Laplace transform. So if f of t is sin hat, what is Laplace transform of sin hat? I hope you remember the formula, right? That is, this is the standard formula. A Laplace transform of f of t is equals to integral 0 to infinity e power minus st f of t dt, which is equals to f of s, right? So you have to always remember this formula whenever you derivate the standard form of Laplace transform. So now let's start with our Laplace transform of sin hat, right? Laplace transform of sin hat. So you can write it as integral 0 to infinity e power minus st. What is f of t? F of t is sin hat dt, right? So integral 0 to infinity e power minus st. You can write sin hat as e power at minus e power minus at by 2, right, into dt. Now, so you can take this 1 by 2 outside, which is common. Integral 0 to infinity, multiply with this e power minus st, that is e power minus st into e power at minus e power minus st e power minus at for whole thing dt. Now 1 by 2 integral 0 to infinity, this is in the form of a power m into a power n, which is a power m plus n. So you can write as e power minus s plus a into t minus, this is also same, right, e power minus of s plus a into t into dt. Now apply the integration. 1 by 2 integral of integral 0 to infinity e power minus s plus a into t dt minus integral 0 to infinity e power minus of s plus a into t dt, right? Now 1 by 2 into, so integral of e power at is e power at by a. So this is a, s minus s plus a is a, so e power minus s plus a by minus s plus a, and apply the limits 0 to infinity minus again this one e power at, integral e power at is e power at by a, integral minus s plus a divided by minus of s plus a, apply the limits. Now we have to apply upper limit minus lower limit, right? Sorry, I have forgot to write t here. So where we have to apply for t, you have to apply the limits. So minus s plus a into e power upper limit minus lower limit, that is e power infinity. So e power minus infinity minus e power 0 minus, take s plus a common, by s plus a into upper limit e power minus infinity minus lower limit e power minus of s plus a into t. In place of t you have to substitute lower limit, which is 0, which will be 1 by 2. E power minus infinity is 0 and e power 0 is 1. 1 by 2 into, so 1 by 2 into minus s plus a into, this is 0 and this is minus 1, plus 1 by 2 into s plus a, this is e power minus infinity 0 and this is e power 0 is 1, right? So Now solve this. Take common, take minus common here. So this minus become plus. So 1 by, take 1 by 2 just common, okay, from both of this. So I'm taking minus common here. So it becomes 1 by s minus a. This minus 1 by s plus a. Okay. Now 1 by 2 into, solve this, cross multiply, s plus a minus of, so s plus a minus of s minus a by s minus a into s plus a. So a plus b into a minus b, which is a square minus b square. Therefore s square minus a square. This cancel. A plus a is 2a by 2 into s square minus a square. So a by s square minus a square. So the Laplace transform of sin hat is a by s square minus a square. Now similarly, I guess we can also do for the cos hat, right? I think you understand how you can do that. Just a small change in the sign. I'll explain you that. So cos hat. So Laplace transform of cos hat. Okay. So this becomes our 9th standard form now. Now I'm not erasing this completely because there is only small change, that is you have to just change the sign here also. Wait a second. Cos hat. Okay, so e power minus st, in place of cos hat, the formula is e power at plus e power minus at by 2. Okay, so simply just change the sign, plus plus plus, and here, okay, one second. So till here we have just changed the symbols, right? Now this minus will become minus. One second. This becomes minus. Okay, from here it is minus because this minus plus into minus becomes minus, so here it will be minus, and again here also it becomes minus, but this minus into minus becomes plus, and so I'll just erase from here now. Okay, I hope you understood. Just a small change in the sign, so that's why I'm not explaining again in detail. So now do this, s plus a plus of s minus a divided by s square minus a square. This a gets cancelled, so 2s by 2 into s square minus a square. So s by s square minus a square. So this is the Laplace transform of cos hat is s by s square minus a square. So by this we are ending all the standard forms of Laplace transforms. In the next video, I'll make a list of all the standard forms of Laplace transform we have discussed in one video. Please do also check that video, okay? Thank you. Thanks for watching. Do like, share and subscribe for more videos.